going to show you how to find the golden ratio. The golden ratio has to do with the most pleasing rectangle to look at. It has been said that if the ratio of the sides of a rectangle are in the ratio of the golden ratio, then the rectangle is pleasing to look at. Now, whether it's true or not, I leave that up to you. Construct a rectangle after we find the golden ratio and see for yourself if you like that rectangle the best of all possible rectangles. So first of all, to find the golden ratio, we take a rectangle that we think is the most pleasing rectangle, and we put for the length of one of the sides 1, and for the other side, the side we don't know, x. Now we construct this so that this line sticking out here is also 1, and then we set up a ratio. The ratio we set up is the length of the small side to the longer side, 1 to x, is the same ratio as this longer side x to the entire, both lengths, x plus 1, x to x plus 1. Now, if we could solve that proportion for x, we'd be able to figure out what the golden ratio is. So to solve that equation, it's usually solved, it's a proportion, it's usually solved by cross multiplication. So we cross multiply 1 times x plus 1 is x plus 1. X times x is x times x, or x squared. So now we have x plus 1 equals x squared. So basically, if I put all the terms on the right-hand side, then set it equal to 0, I'd have x squared minus x minus 1 equals 0. Now, if I can solve that quadratic equation for x, I can figure out what the golden ratio is. In order to solve that, the easiest way to solve that is using the quadratic formula, because this does not come out to be whole numbers or integers. If it were, I could solve it a couple of different ways that are a little bit easier than the quadratic formula, but this requires the quadratic formula to solve. So let's use the quadratic formula to solve it. So here's our equation, x squared minus x minus 1 equals 0. Here's our quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The a, b, and c are the coefficients, the numerical values of each of the terms. So the numerical coefficient of x squared is a, which is 1. b is the numerical coefficient of x, which is negative 1, and c is the constant term, negative 1. So we have a is 1, b is negative 1, c is negative 1. We substitute those values into the quadratic formula. So here we have negative b. b is negative 1. So the opposite of negative 1, well, is positive 1. And now we substitute in here b squared. Well, b is negative 1. We have negative 1 squared. Negative 1 squared, of course, is positive 1. Then we have minus 4ac. So it's negative 4 times a, which is 1, times c, which is negative 1. Negative 4 times 1 is negative 4. Negative 4 times negative 1 is positive 4. 1 plus 4 is 5. So here's what we really have. X is equal to 1 plus the square root of 5 divided by 2. We're going to ignore the minus part here. We want the positive solution to this to give us the golden ratio. So x is 1 plus the square root of 5 divided by 2. Now you can simply take and evaluate this with a calculator. So evaluating that with a calculator, I find 1 plus the square root of 5 divided by 2 comes out to be 1.618, and then a whole bunch of other numbers that keep on going forever. Since the square root of 5 is an irrational number, it will keep on going forever without repeating and without stopping. For most purposes, 1.6 is probably good enough. 1.618 is certainly good enough for most of our purposes. So that tells us that the ratio of the sides of the rectangle that will look the most pleasing, the best of all possible rectangles, the most pleasing of all possible rectangles, the easiest to look at, the nicest, the best. The ratio of the sides is 1 to 1.618. So if you take a handy-dandy ruler and you construct a rectangle like this, I suggest you do it in millimeters. So you make this like 1,000 millimeters and you make that 1,618 millimeters. See if that rectangle looks very pleasing to you. Or you can scale that down and make another one with the same ratio of sides. And see if you believe that the golden ratio gives you the rectangle that is the most pleasing to look at. You may or may not agree with that. Now, so that basically is how we find the golden ratio. And an interesting number puzzle also comes from the same thing. The number puzzle would go like this. I have the number 1. I'm dividing it by some number. It's equal to that number minus 1. 1 divided by what number is what number minus 1? Where n will be the same both places. If you solve this, this is equivalent to solving the quadratic equation that we just solved, and you will get, well, here's our answer. 1 over, well, the golden ratio, 1.618, is equal to 0.618. 1 minus 1.618 is 0.618. So there's the solution to that. So if you take and do this on a calculator, if you take 1 divided by what we just calculated, if that's still sitting there on your calculator, do 1 divided by the last answer, and up will come 0.618. It's identical, except it's missing the 1, because we subtracted it away. So that's just a little curious result that we have. It's a nice little number puzzle using the golden ratio. So again, we're trying to find the length of this side. We solved the quadratic equation to do it. It's called the golden ratio. We figured out that this is the answer exactly. And then here's what it really is that we can use, 1.618. And then finally, we take and make up a little number puzzle. Little number puzzle. 1 divided by what equals what minus 1. Very difficult to figure this out by trial and error. It really helps to solve this using a quadratic equation. Then, of course, you'll get the right answer instantly, well, most instantly, and you will have known more about the golden ratio than anyone you know. So I'm going to say, happy golden ratio and happy computing.